All right, hello, folks. This video is going to be a little shorter than yesterday's because this one's just over the classifications. And for the most part, the notes explain the key stuff or explain the general details. I want to make sure to point out to you, though, some of the really important stuff in these notes. So that's what I'm going to focus on, the key defining features for each of these. And I want to make sure you know where some key stuff is on the periodic table. So yeah, that's what we're going to start with. Okay, I do want to mention once again, I do have the notes open over here. So if you feel like I'm leaning off to one side, that's why. All right, so we are going to be looking at the periodic table again. So if you don't have one of these, you should grab one. And in the classroom, there is a large periodic table. I think I mentioned it in the last video. You might want to make sure that you can see that from wherever you are. So, we are going to talk about the main four classifications of elements. There are arguably five, but we're not going to worry about the fifth one today. Okay, they are pretty straightforward. Metals, not metals, which we call nonmetals, things that are both, which we call metalloids, and then hydrogen, which does its own thing, and it's really annoying. Okay, those are the four classifications. Metals, nonmetals, metalloids, hydrogen. Of those four, metals and nonmetals are probably the two most significant because they are the two that we compare all the time. Of those two, metals is the one that is probably arguably the most significant because we called the second most significant. Hey, it's not that. So that should be a tip off for you too. Most of the periodic table is metals. Okay, so if we look here at the periodic table, okay, there is a feature on here that you have to know or be aware of in order to identify all of these. So it is this slightly bolded line that runs over, down, over, down, over, down, over, and down. Okay, this bold line or bold zigzag is called the stair step or the staircase. Okay, and it is the dividing line on the periodic table. Okay, so I guess the first one we're actually going to talk about is going to be metalloids because that bold line identifies the metalloids. Every element that touches the stair step, and by touches I mean shares an edge with. So, for example, boron here has an edge that is on the stair step. Carbon's corner touches the stair step, but neither of its sides or edges do. So carbon is not a metalloid. Boron is. Okay? So there are 13, no there aren't. There are 9 elements that touch the stair step. Boron, aluminum. Oh man, I cannot read that. That's probably silicon, gallium. No, that's germanium. I can't see. Yeah, germanium, arsenic. I'm just going to move it over here. Antimony, tellurium, polonium, and that last one there is astatine. Okay, so those are the 9 elements that touch the stair step. One of those elements, because of course it can't be that easy, one of those elements is not a metalloid. Okay, and if you think about it for half a second, you can probably figure out which one. It's aluminum. Aluminum is not a metalloid. It's a metal, which shouldn't come as a huge surprise to anyone who has ever handled an aluminum can or aluminum baking sheet or anything that's made of aluminum. Aluminum is obviously a metal. Okay, so you have to remember that aluminum is a metal, not a metalloid. But every other element that touches the stair step is a metalloid. Okay, now, given where aluminum is here, it should indicate to you where the metals are on the periodic table. The metals are everything on this side of the stair step. So everything straight down below and all the way over. So all of these things underneath, this big chunk in the middle, the F block, and these elements over here. All of those are metals. Again, with one exception, hydrogen. Hydrogen is not a metal. Hopefully you didn't need me to tell you that, but hydrogen is not a metal. What's left is everything on the other side of the stair step. Those are the non-metals. Okay, so the stair step here, 8 of the 9 elements that touch it are metalloids. The one element that touches it and is not a metalloid is aluminum, which is a metal. Everything on this side of the periodic table is a metal except for hydrogen. And everything on this side of the periodic table is a non-metal. Those are your 4 classifications, and that's how you can identify them by looking at the periodic table. Now, the key information about each, chemically, there is a defining characteristic that dictates whether or not an element is a metal or a non-metal. Metals, in order to be metals, must lose electrons. They are incapable of gaining electrons. They have to lose them. Whenever a metal forms a bond, it is obligated to lose electrons. That's what makes it a metal. Okay, and this is the most common state of elements in the universe, at least from the elements that we have discovered. Okay, of all of the elements on here, of all 118, I think 90 of them are metals. Okay, so that's pretty common. Most of them want to lose electrons. Now, non-metals, by their very name, should make it clear to you that they are the opposite of metals. So if metals lose electrons, care to take a guess? I hope you said gain, because yes, that's what they do. Non-metals will always be obligated to gain electrons when forming bonds, or doing this thing called ionizing that we'll talk about later. Okay, metals must lose, non-metals must gain. Now, it would seem that those are the only 2 possibilities. They can either lose or they can gain. There's not really much else. So what the heck are hydrogen and the metalloids? What makes them different? Well, metalloids can do both. Metalloids are capable of either gaining or losing. Now, most of them have a tendency to do one or the other. Like boron usually loses electrons. Not always, but usually. Likewise, silicon tends to gain electrons. Not always, but usually. So there's some definite trends in metalloids, but they're there because they're weird anyway, so it shouldn't be a huge surprise that there's some exceptions in there. But metalloids can do either. And then hydrogen is often its own deal because it's got a lot of things going on. Technically, hydrogen should be a metalloid. However, it only exists as a solid at 2 Kelvin, which is something like negative 480 Fahrenheit. And if it's, yeah, and the liquid is at 4 Kelvin. So every temperature above 4 Kelvin, hydrogen is a gas. So we can't see it as a solid, so we don't know how well it conducts electricity. We don't know a lot of stuff about it. But technically it should probably be a metalloid. But just based on that and several other things, and as we go through chemistry, especially those of you who go on to Chem 1, as we go through chemistry, you're going to learn more and more and more about why hydrogen just kind of sucks. I say sucks. Why hydrogen is unique. It does its own thing, and it's proud of it. It doesn't care. And so it's in a classification all by itself. So, in review, before I stop recording and go to bed, metals must lose nonmetals must gain, metalloids can do both, and hydrogen is weird. That's your 4 classifications. With that, a good night. Or, I guess for you guys, it's probably morning or afternoon. So, whatever. Bye.